Okay, guys, this topic is mean absolute deviation. It's one of my favorite topics because I'm a statistics guy. I probably should admit that. But the bottom line is this is going to seem really complicated, but I think after you see how it's done, you'll see it's pretty simple. So bottom line is this. You're going to be given a set of data. So I've put 6 sets of data up here at the top. We're going to call these test scores. So my data is 84, 68, 72, 96, 160. So in other words, it is just these numbers right there. Those are our test grades. So when doing a mean absolute deviation, the very first thing you have to do is you have to find the average of the data that you've been given. So I added 84, 68, 72, 96, 160 all together. And everybody should know how to find the average at this point in 8th grade. That's you add up all the data and then divide by however many there are. So I added them all up. I divided by 6 because that's how many numbers there are. And I got an average of 80. All right, so your next question is probably, well, what are all the numbers in red? And so here's what mean absolute deviation is. What mean absolute deviation does is it tells you how far the data is deviating from the average. So what you're going to do is you're going to find the average first, which is what we already did, it's 80. Then you're going to subtract each number from the average. So 84 minus my average of 80 is 4. 68 minus 80, 12. 72 minus 80, 8. 96 minus 80, 16. 100 minus 80, 20. And 60 minus 80, 20. So now what we're going to do is we're going to add all of these numbers up, all of the differences between the average and our original data set, our original data, and then we're going to find the average of those. And what that number will tell us is how far our numbers are deviating from the average. So, if I'm a teacher, which I am a teacher, and the average score is an 80 and the mean absolute deviation is only a point or two, well, that means most of the kids score somewhere between a 78 and an 82. If I have an average grade of an 80 and the mean absolute deviation is like 20, then that means on average my kids are somewhere between 60 and 100, which the 100 part really good, the 60 part not very good. And as a teacher, what that would tell me is basically that they're all over the place. So this is an excellent, you always want to have an average to get an idea of how a class is doing, but you also want to see how far are they going away from that average. Is everybody pretty much around whatever your average is, or is it really far from that average? So we're going to find out. So I'm going to add, let me see if I can get that in there. I'm going to add 4 plus 12 plus 8 plus 16 plus 20 plus 20. So that should be 1, 2, 3, 4, 5, 6 numbers. Add all those up. It's 80 divided by 6. Wow. So we're looking at a mean absolute deviation of 13.3. So that's probably not the best news. If I'm a teacher and my average isn't, obviously I'd want my average to be a little bit higher, around 85, 90, or, you'd love for it to be 100, but it's not going to work out that way every time. But I would love for the average to be a little bit higher. A lot of the time our test grades, our averages are usually somewhere between 80 and 85. So if I was, 80 to 85 and my mean absolute deviation was say 2 or 3 points, then I'd be pretty good. That means they're pretty much around the 80 to 85 range. But with a mean absolute deviation of 13, that means on average my grades are 13 points lower, or can be as far as 13 points lower than 80. But the good news is that it can be 13 points higher than 80 also. Obviously, the ones that brought that down are like the 68s and the 72s. And even the 100s adds to that mean absolute deviation, because it's not just how much below the number, it's also how much above. It's how far each data set is from the original or from the average. So, and if you look at them, you can see 84 is pretty close to 80, but 68 is pretty far. 72, but 96, 160, all 3 of those are pretty far away from the average, which is why the mean absolute deviation was so great. So once again, what do? You take all your original data set, you add them up, and you divide by however many there are so you can find the average. Then you subtract each set of data from the average so you can get the difference, and then you average those numbers. When you average these numbers, that will give you the mean absolute deviation, and that is mean absolute deviation. And the reason I put M.A.D is that's obviously the abbreviation for it.